Okay, so I think the instructor here just wants you to put in the absolute value function.
Absolute value function. Okay.
Yeah.
Okay.
I guess this is a little bit awkward because it's not very clear what exactly they want, but we'll give it our best guess here. Okay. So it says, how would you model distance with mathematics? Okay. So your distance is, they're trying to get you to determine the definition of the absolute value. The absolute value is this piecewise function. It's x if x is greater than 0, and it's minus x if x is less than 0.
Okay. Okay. So I have to write that?
Yeah, I think all of that needs to be written down.
Okay. All right, I'm gonna write it down.
Great.
Okay.
Let me know when you've got it all down.
All right, you got it. I got that down. I got it down.
Okay. I'm just going to snip in the next part here. So part B. It says, how would you write the distance of 5 miles to or from someplace 8 miles away? Okay, so what it's saying is you're here. This is you. And I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. This is the someplace. Let's just call it A for now. That'll make it easier. Okay. So what they're trying to describe here with this, I believe, let me just double check that. That is okay. To or from. So I believe what they're trying to get you to see here is that you can either go 5 more, 1, 2, 3, 4, 5. Okay, so this is a distance of 5 right here from A, from someplace, or you can go the other direction, 1, 2, 3, 4, 5, and go here, 5 away. So how would you write the distance of 5 miles to or from someplace 8 miles away? So I think what they're trying to get you to see is that it could be the following. It could be 8 plus 5. 8 plus 5 is 13, or it could be 8 minus 5, which is 3. Do you see how this is 3 away here? I don't know. This is worded very strangely. I think there's a better way to do it, but this is what you have in front of you. So we'll just work our way through it.
Okay. Do I have to write this? Let me write that.
Yeah, I would get this picture down. I would write the equations down. Basically everything I put on the page today, you'll want to get down in most cases.
Okay.
You have all that down?
Yeah.
Okay. All right, so here we go. Here's the next one. It says, write an equation of plus or minus 5 feet from something 312 feet away. Okay, so the picture is you're here and there's something 312 feet away, but it could be a little bit left of it and it could be a little bit right of it.
Mm-hmm.
Okay. Okay, so you're X and you're 312 feet away from something.
Yeah.
Sorry, this is not right. X equals the absolute value. I'm sorry. Why? Let me sorry, let me do this differently. It's either you're either 312
Yep.
plus 5 or
So what?
I'm sorry, or you're 312 minus 5. Like plus 5 is over here to the right and then minus 5 is here to the left. Do you follow that? Sourish, are you with me? Sourish, are you able to hear me?
Hello.
Hey, Dr. Kithari, we are
Yeah,
ready.
hi. Now it's,
All
yeah,
right,
it's
we'll
working
keep
now.
we'll
Okay.
keep going.
All right. Thanks. Okay.
Okay,
Hey, Sourish. So
yeah,
here's where we
let's get
left
on.
off. It says write an equation of plus or minus 5 feet from something 312 feet away. So this is numerically what it is, but the equation we can actually write with absolute value. We can actually write absolute value of x minus the center. You are seeing my screen, is that right?
Yeah, I can see your screen.
X minus the center equals the offset. Okay,
Okay,
so in this case, 312 is your center and 5 is your offset. So the equation is x minus 312, absolute value equals 5. This is what they're looking for. Picture explains it. It's up to you what you want to put down, but we're going to write a few of these.
okay, I'm writing it down. I'm writing it down.
Sure.
Okay, there we go.
All right, so let's look at part D. Let me get back to where I can snip that in. Okay, if someone tells you that they will meet you in 4 hours with a leeway of 5 minutes, so that's 5 minutes is your margin. And what that means is you can either be minus 5 minutes or plus 5 minutes.
Okay,
Okay, so it's essentially two equations. It's 4 hours plus 5 minutes, or it's 4 hours minus 5 minutes.
okay, yeah,
So because time is a little bit different, this is 4:05 or 4 hours and 5 minutes. This one is 3 hours and 55 minutes. You know, time isn't base 10, time is base 60 in minutes. But anyway, nevertheless.
okay. Let me just, okay. All right, okay.
Got it down?
Yeah,
All right. Okay, what is margin of error? So margin of error is this, I've been using this word offset. Your instructor uses the word leeway.
yeah,
It's that, like, you can be 5 minutes late or 5 minutes early. It's you know, the thing in the distance is could be 400 feet away, but it could be plus 5 feet, could be minus 5 feet. So margin of error is this, like, it's this, like, what it really is, it's the difference between
yeah.
the expected and the actual value. Have you taken chemistry yet?
Chemistry, no, not yet.
Okay. Chemistry labs and a lot of lab reports you may do someday, they all ask you to calculate margin of error. They want to know, like, what is the expected value and what did you actually get when you did the experiment? Okay, so your margin of error is the absolute value of x minus the
Yeah,
true value equals this margin. Okay, so
okay,
you definitely need to write down this equation. That may or may not be what your instructor wants, but more importantly is, like, understanding this concept, which by doing a few examples, I think we'll get it here.
okay.
I don't know why your instructor keeps asking it this way.
Yeah, I just don't even know.
How would you model margin of error with mathematics? The absolute value function, because that's all you've been doing here, the absolute value.
Yeah.
All right, so next one is, how would you write the margin of error as distance of 5 miles to or from someplace 8 miles away?
Yeah.
It's three distance. That's really odd. I think what they're saying is that it could be 8 plus 5, or it could be 8 minus 5.
8 minus 5.
Yeah. Because the 8 is like the known value, and then this 5 is your margin. So you always add the margin and then you subtract the margin.
Yeah.
Let me know when you get this down and we'll work on the next problem.
Okay.
You got it?
Yeah.
Okay, this one will make more sense. We've got 3 problems in a row where we have to do the same thing. So the equation is always the following. It's the absolute value of x minus your center equals your margin.
Yeah.
Okay, so in this problem, your margin is this number right here. So that goes on the right hand side. Do you see that? It tells you the margin is 0.01. The center is the other number. This is the center. The center is 1000. Okay, so this is what you have to write. And it comes from the equation above. X minus the center equals margin.
Mm-hmm.
So that's what you want to remember, is that equation. That would be really helpful here.
Okay, there. Are we now now
do
number 3?
Letter D, yeah. Let me get where I can snip that in.
Are we now in number 3?
No, we're on letter D.
Okay.
That's just letter C. Oh, your instructor is doing some weird things here. So, oh boy. Okay. So the difference between this problem and the last problem is this symbol right here. What is that? What is that symbol? Do you know?
The percentage, like,
It's a percent, right? And okay, so in math, we don't really use percentages. You want to convert 0.03 to a decimal, and it already is a decimal, but it's paired with a percentage. So the correct answer is we have to divide by 100, which you may or may not have seen this yet. You have to move the decimal place over 2 places. So if that's not clear, just go ahead and get it down anyway. We're gonna emphasize something else in this problem. The margin though, the margin is this number down here. And this is your center. So it's always x minus the center equals the margin.
Okay.
So the center is 1000.
Mm-hmm.
And the margin is this other number over here off to the right, the 0.0003.
Okay. Okay.
E, one more, sorry.
It's fine. It's fine. It's
It's
fine.
these are not good questions.
I don't even know why did Mr. Brown has explained to us.
Yeah, I mean, so even so adults don't like percentages. They're
Yeah.
they're so okay, so all right, actually there's a small thing here, but I'll get to that in a moment. So in this problem, you have to take 238,900 and you have to multiply it by this number, okay, which is we have to convert that again to a decimal. So it's 0.0003. So you're gonna multiply 0.0003. So I'm gonna grab a calculator because I don't know this off the top of my head. 238,900 times 0.0003. This is 71.67. This is your margin of error. That is your margin of error.
Okay.
So your margin of error is this number right here. So you take the centered number, 238,900, and you add the margin, and then you take 238,900 and then you subtract the margin. So you have to take 238,900 plus 71.67, 238,900 and subtract 71.67.
Yeah.
Okay, so if you got a calculator, you can do that. I'm gonna also do it here on my side. So this is 238,971.67. And then the other one is 238,828.33.
Okay.
All right. All right, so there's a lot here in 3. So again, it's kind of odd. Like the main thing is the table with the parent function. So we're gonna snip that in and we'll just kind of work through this. We actually did this in the previous unit. Absolute value of x was one of your parent functions. So the function here, we're gonna start with C. We'll go back and answer A and B, but we're gonna start here with C. Okay, the equation is the absolute value of x. So y is the absolute value of x. So for every number over here, you have to take the absolute value of it. The absolute value of -3 is 3. The absolute value always returns positive. So the absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. It just returns the positive number. In the case of 0, it just returns 0. The absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of 3 is 3. So you definitely want to get this down in the table.
Yeah. I'm writing it down.
Great. Just let me know when you're all done.
Yep. There we go.
Great. So let's go back and do A and B. A says to give a definition. Definition is like distance. That's the first question that we're asked today. So you can think of absolute value as the distance from something.
Mm-hmm.
That's a reasonable thing. Now, an example, we can go back to one of the previous problems, I guess, and talk about like these are so weird. Like let's say the question 1D, if you want to go back and look at 1D, it says 4 hours plus or minus 5 minutes. That's kind of an example of absolute value.
Yeah.
Yeah, it's not great. There's better ways to actually explain this, but all right, so the next thing we're gonna do is we're gonna graph these data points, these X and Y values from up here, from this table.
Yeah.
So we're gonna graph those here. So just follow along here. It's 0, 0, 1, 1, 2, 2, minus 1, 1, minus 2, 2, and minus 3, 3. So notice it's like a V shape.
Yeah.
So this is the graph of the absolute value of X, and it has a V shape, not a U shape, a V shape.
Okay, let me just write that graph down.
Sure.
Okay.
You got it down?
Yep.
Excellent. Okay, so to answer for A, for B, and for C, I'm going to just do a quick demo so you can see what it looks like. Okay, and then what I'll do is in the notes, I'll put the answers down so you have them for later. But I want you to just follow along here after I go ahead and snip this in. So I'm going to switch to Desmos. If you remember, we looked at that last time.
Yeah. Yeah.
Okay, so this is the absolute value of X. Do you see that nice V shape? Hopefully you see that on my screen.
Yeah. Yeah.
Excellent. Okay, so if I go +1, what happened to the graph? Maybe you didn't see that. What happened to the graph there?
Maybe it did it. Did I did it? It changed to Y.
It moves it. Now, okay, so let me try something different here. Watch this, okay? What's happening with the absolute value function? Which way would you describe that moving? You play video games. Which way is that moving?
That moves to the it moves down.
moves down, and then it moves up, and then it moves down, right? So do you see how if I have a negative number, if the value next to the absolute value function is negative, it goes down? But
Yeah.
watch this case. See on the left here, see how the K, when it's positive, it's up above the x-axis. Do you see that? Maybe.
Yeah. Yeah.
Okay, so if we write the absolute value of x plus 2, see how it's above the x-axis? And if I go -4, see how it's down?
Yeah, it's down. Yeah.
Okay, so see how the number on the right here, that's what decides whether it goes up or down.
Okay.
Right. So let me go back to the other screen and I'll show you what you want to write down. Okay, so if you're seeing my screen here, it's shifted up or down based on this K value, this number off to the right. If K is positive, it's a shift up. If K is negative, it's a shift down.
Yeah.
Go ahead and write that down. That may be it for today. It may be all we can get to.
Okay. Let me just write that down. There we go.
Great. Why don't you go ahead, let your dad know we're all done for today?
Okay. Dad. Thanks.
Hi, how did it go?
It went okay today. Nothing to do with him. Just this was a kind of a strange assignment he was given. But you know, he followed along as best he could with absolute values. There's it's a little bit strange the way the instructor presented this, but maybe he's doing something in class that I don't know about. But we did not get through everything, so we can just pick that up next Tuesday.
Okay.
Unless you guys need that, unless you guys want to add another session, but I would just recommend picking it up on Tuesday.
Okay, no problem. Next week, Tuesday. Yeah,
Yes.
Tuesday and Thursday. Yeah.
Cool. All right. Well, that's
Okay.
that's all I got for you tonight.
Yeah.
All
Thank
right,
you.
bye.
Have a great weekend, Sourish. Thank you.
Yep.
Bye now.
Bye.